All right, let's jump right in. In any job where the stakes are high, we're talking coding, engineering, even medicine, the tiniest, smallest details can have absolutely massive consequences. So today we're going to talk about a skill that honestly gets overlooked all the time, the art of precision reading. We're going to break down how you can learn to read what's actually there, not just what your brain wants you to see. Okay, picture this. You've just wrapped up a really complex, high-pressure task. Maybe it's a technical exam or a critical project for work. You felt great about it. You even ran a quick check, everything worked, so you submitted it feeling pretty confident. But then, the result comes back. And it's a total failure. A big fat 0. Man, that feeling is just a punch to the gut, right? And it leaves you with this one burning question. How? How is it even possible that your work, which you saw was working, was worth absolutely nothing? It's a critical question, and the answer, well, it lies in a really common mistake that can trip up even the most seasoned pros out there. So let's look at a real-world example from one of those notoriously difficult IT certification exams. So a candidate, they configured a network protocol, the rules that let computers talk to each other. They ran a test, and boom, it works perfectly. But they still got 0 points for the entire task. Why? Because they missed a single crucial constraint that was buried deep in the instructions. And here it is. This is that critical gap between what you think you did and what was actually required. The task specifically said a maximum of 3 hops, but the candidate, they just built a perfectly functional setup that completely missed that one little detail. The problem is, an automated grading script was looking for exactly that parameter. It didn't find it, so it assigned 0 points. No partial credit. No, you were close. Just 0. So you might be thinking, well, that's just carelessness. But it's not really that simple. The problem is actually much deeper. It's about how our brains are wired. See, under pressure, our brains are built for speed and efficiency. And that instinct, it often works directly against the kind of meticulous, perfect precision that modern systems demand. And these are the 3 main culprits. First, you've got familiarity bias. You've done a task 100 times before, so your brain just goes on autopilot and assumes this time is exactly the same, and it skips right over the new details. Then there's information overload. That's like trying to find one specific snowflake in a blizzard. The key detail is in there somewhere, but it's just lost in all the noise. And time pressure? Oh, that just makes everything 1,000 times worse, forcing you to skim when you really need to be analyzing every single word. So take a look at this. It's a perfect example of that information overload problem. Imagine this is a dense block of technical instructions for a project. Now, buried in this wall of text are 5 separate, non-negotiable requirements. When you're under pressure, the clock's ticking, how easy would it be to just scan this, get the main idea, and completely miss 1 or 2 of those little details? And here they are, pulled out from the chaos. You have the main task, a very specific advertising rule, an explicit negative constraint, something you must not do, a naming convention, and even a performance metric. And the crazy part is, if you nail 4 out of 5 of these, but miss just 1, like you forget not to advertise that one subnet, the entire task is considered a complete failure. So if our brains are basically wired to mess this up, what do we do? How do we fight back? Well, the answer isn't to just try harder, it's to use a better system. The solution is a methodical, repeatable process that's specifically designed to beat these cognitive traps, and it's called the 3 reading strategy. Okay, here's how it works. Your first pass is fast. You're just skimming to get the big picture. What's the main goal here? Your second pass is slow, really deliberate. You are hunting for every single requirement, every constraint, every little detail. And then the third and final pass is a micro-level check for absolute precision. Are the names spelled correctly? Are the values exact? Is the capitalization right? And I know what you're probably thinking. 7 to 10 minutes just to read? It feels totally wrong, especially when that clock is ticking down. But you have to trust me on this. This is not wasted time. This is an investment that prevents catastrophic failure. This is what separates getting it almost right from getting it exactly right. Okay, so a strategy is one thing, but you need some actual tools to put it into action, right? So let's look at a couple of super powerful practical techniques that you can start using to implement this strategy, like today. Just look at the difference here. It is night and day. On the left, you've got this vague, kind of useless note that's super easy to misinterpret, but on the right, a rock-solid, detailed checklist. When you deconstruct the task into these small, specific, verifiable steps, you create a roadmap for yourself. It becomes nearly impossible to forget a requirement when you have to physically check it off a list. Here's another great one: color coding. Just assign a different color to each type of information. So the main goal is green. Things you must not do are yellow. Specific numbers and names, those are blue, and how you're going to prove it works, that's pink. This visually forces your brain to slow down, to actually engage with the text, and to categorize every single piece of information you're reading. And all of this leads to one single, non-negotiable truth. We have to learn to read like a machine thinks. Because in today's world, more and more, our work isn't being checked by a human who can guess our intent. It's being checked by automated scripts, by compilers, by systems that are completely and utterly unforgiving. This brings us to this core idea of script-specific precision. An automated system doesn't care if you were close. It checks for an exact match. If it expects an uppercase A and you give it a lowercase a, you fail. If it expects the number 5 and you type 10, you fail. There is simply no room for error. Period. Okay, get ready for this one because it's painful. The task required an access list to be named LAN traffic, all caps. The candidate named it LAN traffic, all lowercase. Now, to a human, that's functionally identical. But to the grading script, nope. It's a completely different string. Total failure, 0 points. Or how about this one? Just as brutal. The required value was 5, the configured value was 10. Now, the candidate understood the concept perfectly. They knew what command to use, they knew why they were using it. But they got the specific value wrong. And again, the results is exactly the same, 0 points. The machine doesn't grade your understanding. It only grades your final output. So this brings us to the final thought to leave you with. This isn't just about passing some exam. It's about a fundamental shift in how we approach any kind of detailed work. So the next time you're looking at a contract or writing some code or configuring a critical system, I want you to ask yourself this question. In your work, where is your one-word mistake hiding in plain sight, just waiting to cause a massive failure? Because your ability to find it, that is what separates good work from truly great, reliable work.